Good day, Mike Mata here. Again, going to show you another NetData video on someone complaining slow FTP transfer. So we're going to dig into this here. We can see some good information here if we just highlight that conversation. Let's make that bigger. So we've got minimum round trip to set up that connection, 102 milliseconds on the data. There is what I'm focused on. We can see the window size, client, window size, server. There was one retransmission and a selective ACK, duplicate ACK. Our inbound and outbound, throughput, if you will, we hit a maximum of 75K BPS from the server data transfer. That's pretty slow. Think of old modem days, right? 75K transfer. Ooh, glad. That's almost like my DSL link that I'm on sometimes from my internet service provider. Unnamed. Begins with a C, ends in a link. Kidding. Okay, so if we plot that, let's plot just that server and let's take a look at it. See how things go. Click and let's just chart only the records of this server and clear the data loaded. No, let's use what we've got. So we can see there was some transactions down here pretty fast, starting probably connections, client to the server. But you notice we have this one up here that's hanging out about 400 seconds. That's kind of a long time. So again, if I put my mouse there, it will tell us client .100 2000.100 and server, the response it sent back 35,553 bytes, basically 3 meg there, and it took about 400 seconds to do that. So let's see if we can't drill in and learn a little more about what's going on with this. If we focus here on just that, let us look at the timing. Here's our packet timing. Make that a little bigger so we can see. Actually, let's make that a little smaller. That's a lot of information here that NetData gives us. Your different connections going on. We can see the different server service time, response time, data followed, gap, if there was a selective ACK, data retransmitted. So let's do a little digging into this here by looking at the flow. And so we can see the flow. Again, let's make that a little smaller if we can. There we go. Let's make this a little smaller here. Okay. We see it start. We get up to about 75K. Again, the dotted green line there is the server kbps. If we look at our traffic rate over here, server kbps, we hit a maximum there of about 75 kbps. Let's see if we can look at any of these. If I highlight these, there we go. So we can see our round trip time, 112 milliseconds. Looks like that line's roughly about 100 milliseconds ish there, and these were about 160, 180. So we've got some pretty long ACK times there, 160 milliseconds as well. So let's see if we can figure out what's going on. Let's go back, let's close that and go back to our packet timing. Okay, and let's look at this a little deeper. So if we start up here at the beginning, and we'll zoom into the beginning, we can see, well, wrong window. We can see here, if we set our cursor on it, this should be the sync request, which it is. Alright, let's make that bigger so you can see it. We can see it's a sync request. Round trip time 102 milliseconds. So again, three-way handshake takes 102 milliseconds, but what we also want to pay attention to, max segment size 1460. It's going to use window scaling with a factor of 3 there, and selective acts are permitted. So client, this is the whole client start negotiation process. If we look at the sync act from the server, we'll find that. We'll put our packet number 2. We'll just again focus in on that for just a second. Let's see what it's going to do. So 1460 max segment size, server, window scale 0, and selective acts. So those of you that know your TCP, selective acts most efficient in starting a connection, doing retransmits. Window scaling, we can increase the value size of our receive window beyond the default 535 bytes or 64K that's default in the TCP header. And max segment size 1460, most efficient for moving data across a 10 meg, 100 meg, Ethernet segment with a 1518 byte frame size. So that all looks pretty good, and that's what we'd like to see. But if we start drilling in here, we kind of see these little gray gaps. Let's take a peek in that. Let's drill into that a little deeper. And you'll see here's an ACK. If I set my cursor there, there's an ACK. Round trip time of about 112 milliseconds, 112.4 milliseconds. And again, that's a little slow. But if we follow the line, you'll see there are 2 packets up here. Here's our first one, IP ID of 46532. So there's our first packet, 46532. We're sending a full packet, 1518 bytes, data of 1448. Well, we said segment size should be 1460, so we're not sending the full 1460, we're sending 1448 there. The next one, let's set our cursor there, 46533. Again, we're sending 1448 bytes here. So 1448 plus 1448. There's our 2 segments. Let's drill into this a little deeper, make it easier to see. So there's the 2 segments that are sent. We get an ACK for those 2 segments right here. And that takes, there's our ACK. And then here's the 3rd segment that gets sent of 24 bytes. And then the ACK for that is way over here. Now I say way over here, that's based on time. If we look at our time across the top, there's our ACK for that 3rd packet, but that took an additional 112 milliseconds. If we see that right there, 112 milliseconds round trip. That's that delayed ACK timer, because we sent 2 packets, got an ACK, and then 1 packet, and Windows waits. There's the delayed ACK timer. Now, even some funky math going on there. If we fire up our calculator and do 1448, there's our how much data is being sent in those 2 packets, plus 1448. It's 2896. That's kind of an odd number, because 1460 and 1460 would be 2920. 20 since our max segment size was 1460. So we're a little off, and you notice that third packet, if we add 24 to this, there's our 2920. So it looks like what's happening is it's, you know, kind of messing with segment size stuff. We told it to use the max segment size of 1460, but it's only sending 1448, and then the 24, and that's why we're getting those 3 packets. And then that whole process then of that third packet is slowing everything down by adding the delay timer. So this is killing the throughput. So this is how we can use NetData to figure out, again, things that are going on with our trace from a Wireshark trace. I was able to see very quickly, you know, this is definitely going to be a problem and cause life to be slow and people to complain. If I, you know, go to the right, we can also, you know, see the process continues. 2 packets, 1 ACK. We'll continue to go to the right here, scroll to the right a little bit. We see it again. 2 packets, an ACK, and then another small. And you notice these black lines are at the top. So that's, you know, full packet. And this one down here, small packet. So that's another indication. You know, 2 full segments, 1448, and then another 24. Again, we get the 1 ACK for the 2 packets. And then the ACK for this one, you know, over further. It's actually off the screen. And there it is. There's the ACK for that last packet. And again, that one takes another 112 milliseconds. So we start doing that a lot, and now all of a sudden we have a lot of time. We're just waiting. So hope you enjoyed the video. Thanks. Make it a great day. May the frames be with you. How to use NetData.